yeah, I'm going to give you an idea of some of the basically how you access SpiNNaker through the Jupyter system, mainly through eBrains, and sort of how it's linked to the eBrains system, and give you some examples of things that we've run on the system. Some very small examples at this point, because large examples don't work so well in small demo sessions. So let's see how we get on. So yeah, basically we can go into the eBrains collaboratory. You log in, you can go and find some collabs. If you set this up in advance, you may have some favorite collabs, which I have the Neuromorphic Computing in eBrains collab as one of the members. Within this collab, it's already been installed, the SpiNNaker interactive SpiNNaker Jupyter system. You can actually install this in your own collab as well, similar to how Andrew was showing earlier in terms of installing the Neuromorphic platform interface. You can also install this. When you come into this, you get a kind of Jupyter interface that you may have seen in other parts of eBrains as well. I can make this a bit bigger so you can see the whole thing. So in our Jupyter notebook, we have a few examples and tutorials and things. So there's 3 tutorials at the start here, which sort of give you an introduction to running Pine simulations on SpiNNaker, and that's shown here. You can sort of see this, it sort of goes through some ideas of how it all works, and at the end there's some exercises as well. And yeah, there's one on live input and output, and there's also something on how to use SpiNNaker with the Robotics platform, which I'll show you later. There's also access to the eBrains drive here, so if you log in with an eBrains ID, you should be able to access this and see all your different parts that you're linked to in the eBrains. It's not quite the same as the eBrains Jupyter system. They're just slightly ahead of us in that they have this sort of joint access, but we've still got all the shared with groups and things in our access so far. You can also see how we've installed the software as 2 forms, SpiNNaker and SpiNNaker Git. Basically, SpiNNaker is the latest release version, and SpiNNaker Git is a Git mirror, so that you can sort of get later versions as you need to, in case they're not updated in your system. So access there. So yeah, I was saying there's a few tasks with the in the simulation. So this is sort of what you get when you see the tasks. You get a sort of blank pages to fill in the blanks from what you've learned, basically, to sort of test your knowledge. There are also solutions on there if you want. I can sort of show you a running version of a solution here. So when you actually run a solution, it goes through all the different things. You can see the sort of SpiNNaker run going ahead. And eventually, when you get down the bottom, you can sort of see this is what you get if you were had SpiNNaker installed on your own computer. You can sort of see it running through the process of loading things on. We've taken on board that it takes a reasonable amount of time to load things onto SpiNNaker so far, and we'll be addressing this in the future. But for now, you get this sort of system which is running through all the different steps, and you can sort of see it slowly happening. As Steve mentioned, we're sort of allocating boards as they go along, so you can see this process happening here where we're allocating a SpiNNaker board and booting that SpiNNaker board up, and then it does the process of loading everything onto there through various executables, and hopefully it will get to the point where it gets to the end. So it's doing things like expanding synapses on the machine, so we've sort of taken on that part to make that a bit faster at least. For small examples like this, it's kind of doing a lot of work which takes sort of a default amount of time, so larger examples aren't necessarily that much slower. The cortical microcircuit takes about 10 minutes now in total to run. So that's one reason I haven't shown that as an example. So this is going to run for 10 seconds. It's actually on the machine now running, waiting for it to stop, and then it gets the actual data out and plots a graph of it. So you can sort of see a balanced random network here was what was being done. Nice and simple. So we've installed some other bits on the system. You can access the the OpenAI Gym system if you like. I've done this in the past where this is not using SpiNNaker currently. This is just showing you the sort of random example with the OpenAI Gym stuff. So this is a Space Invaders example. But the point is, once you learn the live input and output, you could plug this into SpiNNaker and sort of have live input and output going between the Jupyter notebook and your SpiNNaker and the Space Invaders, for example, and try and do some fun things with that, which we haven't really tried yet. What we have actually been able to do ourselves is run games actually on SpiNNaker as well. One example of this is a breakout simulation that we have running on SpiNNaker, a breakout game running on SpiNNaker. It's not even a simulation, it's just playing, it's an implementation of the breakout game that runs on one of the cores on SpiNNaker. You can then connect that directly to your neural network. So if I kick off this code, just check it's actually in the right state to do so. Should be. This will take a little bit of time again to load everything onto the system. This is using an example that a student has given us. Let me see if I can access. Unfortunately, the Zoom menu at the top is just in my way. This is sort of what's happening here. So it's connecting the output from the breakout simulation. The student worked out, you could work out roughly where the ball was in the X and Y, in the X space, and where the paddle is in the X space, and then connect together a sort of neural network, more of a control system neural network in this case. So it's sort of predetermined connections that works out where the ball is on the system. And when you do this, hopefully when this finishes, you'll see a example of this running on the machine. Let me just, it's just about to load on now. Just doing the last step. And what you can see is this kind of is designed to make the bat follow the ball on the system. Let's just load it up, here it is. So you can see this is basically the neural network playing breakout, which is quite fun to see, and it achieved reasonably good achievement of keeping the ball up most of the time. It does every now and again drop it. I think the system is designed so that it tries to follow the ball, but it's maybe just a touch late. Also, the bat has a certain amount of random input placed into it as well to try and make it work. So that random input sometimes knocks it off course. So there's sort of this part of it. But yeah, that's an example of breakout running, and you can visualize that within the Jupyter Notebook system as well. I don't think that's stored in the default Jupyter Notebook system, but we can make that available quite easily. So the other thing that we've installed in the system is the Neurorobotics environment. So we've actually installed that on the Jupyter Notebook, so you can run your own Neurorobotics environment and run simulations with SpiNNaker. You can start that up from a terminal, so you can actually load terminals in Jupyter and start running things. So there's CLE start, CLE Nginx, I think is the standard command. It's lost all the history of that. I've actually run this earlier and have that sort of running here with an example. Let me just refresh that to make sure it's working. When you go into the system, there's a load of experiment templates. Most of them are standard Neurorobotics experiments, but there's one which involves SpiNNaker by default on the system. And so you can go and have a look at that. I've cloned it here, and what you can do then is launch that on the system, and you should get the Neurorobotics platform then starting up. And it's having a go at that at this point. Yeah, it's loading all the stuff that the Neurorobotics platform loads, of course. Let's hope it actually works today. Having a little bit of fun here. Let me just check it's not doing anything odd. The danger of live demos, of course, is that they're bound to go wrong on the day that you try them out. Having a good think about it. Let me just try refreshing that page. Hopefully it'll load in this time. Okay. If that's not going to load immediately, what I can do is kill the platform and start it again. So let me just stop everything on the NRP and start it. Let's just see, is it still running? That's my environment trying to get into it again. Should be able to kick it. Okay. Let's see how we start. This is actually me starting the system at this point again. Go back in to the platform. It's not playing today, is it? That is typical. Let me just move this out of the way. Yeah, not sure why it's not playing so happily today, but it's here we go, we're getting in now. Join the system, because I've not got the final bit of the URL. There we go. Let's launch it again and see if it works this time. More often than not, it's reasonably stable, but as I said, typically when you're doing a demo, these things are less stable. Here we go. This looks better. It's loading all the information from the Robotics platform in. And you should now see a nice image of a robot in an environment. I'm going to hit the play button, which will load up everything on the SpiNNaker board. Now, similar to before, this takes a little bit of a process. You can actually see this happening in the console. You can see it going through the steps of everything that it loads on the SpiNNaker platform. And the idea here is that we've got this robot in the middle. When it starts up, it'll start spinning, looking for a red color. The screens are both blue, so it keeps spinning. Once I enable one of these screens to turn red, it should move towards it. And then when I turn it blue, it will start spinning again. So let's see how far we're getting. Nearly finished. Expanding synapses again. This is a fairly simple example. Once again, it's more of a control system than it is a brain, I suppose. So it's controlling things based on images in the scene, rather than trying to work out any sort of vision processing. It's just about finished. Let's see, really just about finished. Here we go. I think it's going now. There we go. The robot is spinning around. If we turn one of these screens red, when the robot finally faces it, it'll start moving towards it. And if we turn it blue, it starts spinning again, or it tries to. It's gotten stuck. Yeah, it's spinning again. And then if I turn this screen red, it says, oh, okay, there's some red over there. It starts looking at that. If I turn it blue, then it starts spinning again. So there we go. We've got the robot example as well, linking into SpiNNaker. You can see it's running reasonably fast at this point. So it's running in as fast as the Neurorobotics platform copes with. There's some synchronization between the systems. So if the Neurorobotics platform, if the Jupyter system is very busy, because the Neurorobotics platform, of course, is running straight on the hardware, then it'll slow down the Neurorobotics simulation, and then SpiNNaker will appropriately slow down as well. There's a sort of synchronization system between them. So SpiNNaker can sort of be paused at certain intervals, and the Neurorobotics platform then tells it to move on. So there we go.